In this video, I am going to discuss about normal distribution. The normal distribution is a continuous probability distribution that describes a large class of real-world phenomena. It is also called the bell curve. This is because the normal distribution graph looks like a bell, like this. This is why it is called a bell curve. These are the examples for normal distributions. Exam results: height, weight, IQ level. The normal distribution is often used in businesses because it is easy to work with and provides accurate predictions for many business decisions. This is what a normal distribution graph looks like. The normal distribution graph looks like a bell. That is why this is called the bell curve. This is the y-axis and this will be the x-axis. Now let's get to know about normal distribution and normal distribution graph. These are the characteristics of graphical normal distribution, which means normal distribution graph, which is this. Shaped like a bell curve. Now we know that. Mean, mode, median. The mean, mode, median are equal and located at the center of the distribution. This means that the distribution is perfectly symmetrical. This is very important. This mean, mode and median describes the average. In the context of normal distribution, the mean term is frequently used. As we discussed earlier, this will be the mean value or mode or median. These all values are equal and they located at the center of the graph, which means this line divides the bell curve into perfectly two parts because the bell curve is perfectly symmetrical. These two 50 percentages are representing the symmetry of this bell curve around the mean value. Standard deviation. This denotes by Greek letter sigma. The standard deviation determines the spread of the distribution. A smaller standard deviation means that the data is more clustered around the mean, while a larger standard deviation means that the data is more spread out. Simply, this is the volatility of the data around the mean value. Higher the standard deviation, higher the risk will be. Lower the standard deviation, lower the risk will be. Let's go to the graph. The standard deviation means this graph can be divided into sections like this. How the data is varying around this mean line. Likewise, this bell curve can be divided into standard deviations. Each section is called the standard deviation and each of these sections are equal to each other. Area under the bell curve is 1, which means whole population is represented. This means this whole area under this bell curve equals to 1. Area equals to 1. 1 equals to 100%. The decimal 1 is the representation of the 100%, which means in normal distribution, whole population is considered. You will understand this once we do an example. Now let's discuss about the standard normal distribution. The standard normal distribution is a special case of the normal distribution where the mean is 0 and the standard deviation is 1. Earlier we discussed about the normal distribution. Now here this is a special case of the normal distribution, which is standard normal distribution. These two characteristics you have to remember. Mean is 0 and the standard deviation is 1. This is only applicable for standard normal distribution. When it comes to normal distribution, the mean and the standard deviations can be changed. The standard normal distribution is where this is the bell curve as now we know, and this is the mean value. Mean value equals to 0 and the standard deviation is 1, this distance or this section. Likewise, this is also equals to 1 because standard deviations are equal to each other. So this is 1, this is also 1, this is also 1. And on this side, this is also 1, this is also 1, this is also 1. These are the standard deviations. Simply, these are the volatility of the data around the mean value. Now let's discuss about the z-score. You may have heard of this before. Z-score is a measure of the distance between a data point and the mean of its distribution in terms of the number of standard deviations, which means we are going to calculate the number of standard deviations between a data point and the mean. This is the formula to calculate the z-score. Z-score equals to x minus mu divided by sigma. X is the data point. Mu, this is a Greek letter. Mu, this is the mean value. And we divide this difference by the standard deviation. This is the sigma. You have to be familiar with this formula. This is the normal distribution table. This will be provided in your exam. As you can see, this is the Z value we just discussed above. You don't have to remember this formula. This will be in this table. But once you do example questions, you will get the hang of it. Remember that all these data in this normal distribution table are probabilities. All of these values are probabilities. And let's see how we are going to use them under normal distribution calculations. Here is an example. Results for a maths test were given to the students. Average mark was 45 and the standard deviation was 15. Calculate the probability of students scoring more than 70. As I said earlier, we are going to associate probabilities using the normal distribution table. So there are 60 students, which means this is the whole population we talked about earlier. We are going to consider the whole population for normal distribution. In this example, the whole population is 60 students. We are going to include all of these students' marks. And the average mark was calculated 45. This is the mean value. Average is the mean. Or this can be also called mode or median. And the standard deviation was 15. This is the sigma value. First of all, let's draw a normal distribution curve. This is how you start your calculation. In the exam, these kind of questions will be tested because these won't be lengthy. You have to have a thorough understanding of normal distribution calculations. So, do more example questions. The first step is to draw a normal distribution curve. Here it is. You are not required to draw these graphs in your exam. This is for your rough calculations. So they have given the mean value or the average value, which is 45. And they are asking the probability of students scoring more than 70. So 70 is above the average value because this is 45. 70 should be on this side. So it will be around here 70. What we have to find is we have to find this area because this is the area which represents more than 70 because this is the 70 and all of this area represents the more than 70 mark. So what we have to find is this area, let's say A. Then we can use the z-score formula. Z-score equals to x minus mu divided by sigma. This. And mu is the mean or the average, which is 45 divided by the standard deviation. Standard deviation is 15. 25 divided by 15, which equals to 1.6667. Let's take this as 1.67. So now what we have to do is we have to refer to the normal distribution table and we have to find the probability of 1.67. Let's do that. We have to find the probability of z-score equals to 1.76. First, we have to go along this column this way. 0, 0.1, 0.2 like that. There is 1.6 here. We need the value for 1.67. So now go to this row. 0.01, 0.02, 3, 4, 5, 6, 7. Here. This is the column we need. Here 1.6 and here 0.07. 1.6 plus 0.07, which equals to 1.67. This is the value we need. Now let's find out the probability for 1.67 z-score, which is this. 0.4525. There is no 0 before the decimal point, but you have to take it as 0.4525. Now let's go back. Now we have found the probability 0.4525. We can convert this into a percentage value multiplied by 100 equals to 45 to 5 percentage. This is the answer. Is it? No, this is not the final answer. Look at the graph here. We have found the probability between 45 and 70. This is the probability we just found. 45.25. This is not what we need. We just found this area. Look at the formula here. 70 minus 45, which is this area. But we want this area. So how we can find this area? Area A. We know that the bell curve is symmetric around the mean. So this whole area equals to 50%. And this half equals to 50%. Now we can find the area of A. 50 minus 45.25, which equals to 4.75 percentage. I hope you understood this. This 50% is the half of the bell curve because the bell curve is symmetric around the mean value and we found the area between 45 and 70. Here we can also set this as an area because this is an area under the bell curve. Now let's do another example using the same data. Calculate the probability of students scoring less than 30. First, let's draw the bell curve. This is the bell curve. So this is the mean. Mean was given 45. Sigma is given 15. and they are asking the probability of students scoring less than 30. So 30 is around here because 30 is less than 45. It should be around here. So they are asking less than 30, which means this area. I hope this is clear. They are asking the probability of less than 30. 30 is here. So less than 30 will be the area to this side. Now let's use the z-score formula. X minus mu over sigma. X is 30, mu is 45, sigma is 15. Now this will give a negative value. Minus 15 over 15 equals to minus 1. Don't worry about this negative value because 30 is less than 45. We just deduct 45 from the 30. It is going to be a negative value. But remember, the normal distribution table does not have negative values. So if you get a negative value, just find the probability for the same positive value. Now we have to find the value for positive 1, even though we got the negative 1. Let's go to the normal distribution table. This is what we are looking for. 1 and 0.00, which means 1.0 plus 0.00, which is 1. This is the value we need. 0.3413. So the probability is 0.3413. Let's convert this into a percentage value. Multiplied by 100, 34.13%. Is this the final answer? No, it is not. Look at the graph. We just found the area between 30 and 45. This area. We need to find the area below 30. So now we know this is 50 because the bell curve is symmetric around the mean value. So 50 minus 34.13 equals to 15.87. I hope all clear. From the normal distribution table, we found this area. So essentially this is what we did. This is the curve. This is 45. This is 30. We found the area between these two values, 30 and 45, which is 34.13. But we need this area. So what we did, we know this area equals to 50. So we deduct this area from 50. So we can get this section below 30 value. This is how you calculate the probabilities using normal distribution. This is bit tricky. You have to have enough practice doing example questions. These type of questions will be tested in the exam because these are not lengthy. You just have to use the z-score formula and find the probability from the normal distribution table. Then assign that probability to the graph and find the respective probability. Now let's do this example. Data is same as before. Calculate the probability of students scoring between 30 and 70. First of all, let's draw the bell curve. This is the bell curve. Mean value is 45. They are asking between 30, 30 is here, and 70, 70 is here. Because 70 is higher than 45 and 30 is lower than 45. They are asking this whole area. This is the area which represents between 30 and 70. Then what you have to do is you have to find the Z value for 30 and Z value for 70 like we did earlier. Then find the respective probabilities. Since we did this earlier, here, so the probability for 70 is 45/25. 45/25. This is for 70. For 30, 34/13. 34.13. This is for 30. Now we know the probabilities. So what is 34.13? Which is this? This is 45. This is 30. So this represents this area as we did earlier. So what is 45.25 area? Which is this? This is 70. This area. So now what we have to do is we have to simply add these two values because this is the area we need between 30 and between 70. This equals to 79.38%. I hope all clear. Likewise, now you know how to use the normal distribution and how to use the normal distribution table to get probabilities. Be very mindful in the exam. It is always a good practice to draw this bell curve. This is the reason why we are drawing this bell curve so that we can understand the question properly and answer the question. So first draw the bell curve and understand the requirement. Thank you for watching. See you in the next video.